this video, I would like to show you the reaction between some metals with water. And here is the first one, copper metal. Can you see the color of copper metal? It is somehow brown in color, and it is quite special from other metals because other metals they are usually gray in color. However, for gold and copper, there are two exceptions. They are brown in color or somehow yellow in color. So just recall it. The color of copper, brown in color. And then another one is calcium, Ca with symbol. You see clearly. I use a black background, white background. What can you see? What's the color? Okay, some gray or black solid. And then the next step I would like to do is to pour some water to it, and then we'll see what will happen. For copper and then for calcium, similar amount of water inside. I think you can observe something already is that for copper metal, there is a low observable change up to this moment. However, for the calcium, it shows something already. There are some gas bubble, and then originally the water on the top is clear, is a colorless clear solution. However, now it becomes somehow milky. And if you hear clearly, seriously, you can hear some hissing sound. So what you can observe is that for copper, there may be low observable change, and then for the calcium, when it reacts with water, there will be gas bubble evolve, and you can hear some hissing sound, and then the solution will turn milky or white in color. And if you really touch the test tube wall, it will you can feel that the test tube wall it become warmer. It's because for the reaction between calcium and water, it is an exothermic reaction formed liquefied. It releases into the surrounding and heat up those water. And then you have a closer look of that in copper. Can you see it? No change at all. Calcium. Here's how it looks. And you can also see some white solid on the test tube inside. And here is part 1, the reaction of water with copper and calcium. And then the next two metals that I would like to show you is called sodium and potassium respectively. And here is how they look like. Can you see that there are two colorless trays, one with label sodium and then the other one with label potassium. And then you have a closer look to it. Can you see that they are immersed in some oil, we call it paraffin oil. Then this paraffin oil is different from those vegetable oil or animal fat. They are generated, they are made from petroleum. And the reason why they are stored like this is because it is very reactive. Sodium and potassium, they are very reactive. And this layer of paraffin oil can avoid the contact of them with oxygen and water in the atmosphere to avoid oxidation. 去費事佢哋有同空氣入邊嘅某啲成分啦，會有反應啦，會有氧化嘅情況，令到佢哋可以 store 得耐啲啦。And because of this oil layer, if we would like it to react with water, then we have to use tissue paper to remove the oil first. Just a piece of forceps, and then take out a piece of it for you to observe. And these have an irregular shape, and then put it onto a tissue paper, and then to to remove some of the oil on the top. And then can you see that there is a large tray of water here? Let's have a closer look. And originally, for this sodium metal, it has an irregular shape, a grey in color, and let's see what will happen if it is dropped into water. There are some bubbling, and then it turns into a silvery ball, maybe with some white smoke, and you may hear some hissing sound. And also you can see that this part is somehow irregular, and you can see some golden yellow fire on top. You see that this path is actually quite irregular， 唔係直線咧，唔係有序咁樣喺嗰個水面上面漂浮㗎嘛，佢 randomly 咁樣行嚟行去啦。And you can see that the ball becomes smaller and smaller, and then finally it will disappear. So the reaction is nearly completed. Oh, and here comes the observation for sodium. Oh, and then for the second metal inside those paraffin oil is called potassium. And again, just a similar procedure. Take it out with a piece of faucet and then use a tissue paper to remove the oil on the top. This is how this potassium look like, somehow gray in color with some not very shiny surface. And let's observe. And this time you can see that it disappeared already. Because its reactivity is much higher than that of sodium, so that it reacts quite vigorously. And maybe I show you another one, and you can compare the rate of reaction and the corresponding reactivity by comparing with sodium or calcium. 睇下佢 reaction 嘅速度快定慢。跟住就話我知咧，佢同 calcium 啦，同埋頭先 sodium 比較，邊個 reactive 啲啦？第二就係話咧，佢嗰個嘅澎湃程度啦，同埋個火光呢個顏色都有啲唔同嘅。咁啊，試下遠少少、近少少俾你望下。第二嚿咯喎，一樣次序啦嚇，拎佢出嚟，放落水，咁啊印乾佢面頭嘅嗰啲 paraffin oil 先啦嚇。個鏡頭轉一轉個位先。咁啊，掉佢落去咯喎。Oh, and can you observe the color? And the color of the fire is lilac in color, and the reaction rate, how about the reaction rate? Faster or slower than that of sodium or calcium? Yes, faster and more vigorous. And you can actually draw a conclusion that potassium is a more reactive species than sodium, and sodium is more reactive than calcium, and finally is copper, because copper has no reaction with water at all. And the next question is that you can see that the sodium metal or the potassium metal, it seems like they disappear, is it? If I have a closer look to the solution left behind. And here is those paraffin oil on the top. And do you think that these are colorless liquid still water? Oh, and to show you that, we have to make use of an indicator called phenolphthalein, and this is an acid-alkali indicator. In acidic environment, it is colorless, and in alkali environment, it is red in color or pink in color. And let's drop several drops of it to the solution. Oh, and let's observe. Is it colorless or pink? Yes, it's turned pink, and our conclusion is that this solution or this colorless liquid is no longer water, but it becomes an alkaline solution. And to answer the question previously I asked, is the sodium or potassium, they disappear? And the answer is their metal, they disappear. However, after this chemical reaction, they turn into a soluble alkaline substance and dissolve in water inside. They are just turned into another form instead of in forms of a piece of solid metal, but they form something called compound. 當嗰啲化合物啦，如果嚿嘢佢溶咗喺水，令到啲兜水咧變成一啲鹼性嘅嘢啦。So then you can see the indicator, it turns from colorless and to this pink in color.